All right, so now we're on to sets, inequalities, and interval notation. And so what we're going to do here is we're going to be focused on inequality expressions here. And so hopefully we're familiar with many of these right here, the less than, greater than, less than or equal to, greater than or equal to. And then here are just some examples. So with these inequalities right here, this says -2 is less than a, but also you want to be able to read these in the other direction. So if you're reading this from right to left, it would be that a is greater than -2. Or right here, x is greater than 4, or 4 is less than x. So even though we kind of get used to saying, oh, this is the less than greater than symbol, you do want to be careful and be able to read it from left to right, but also from right back to left. So right here, any value for a variable that makes an equation true is known as a solution. So for example, this right here, if we had x plus 3 equals 6, let's say it was equal 6, our solution would obviously be 3, right? Because 3 plus 3 is 6. But with the inequalities, what's going to happen here is we're actually going to have an infinite amount of solutions. So right here, the set of all solutions is called our solution set, and inequalities have an infinite number of solutions. Okay, so therefore we use graphs and we use a thing called interval notation to describe their solution set. Okay, so my example up here, it's real simple. My solution would just be 3, right? But here it's a little bit more complicated because there's an infinite amount of numbers you could plug in for x to make this statement true right here. And so that's what we're going to look at. And so this will be something that, especially the interval notation, that'll be a notation that we're going to use throughout the semester. Okay, so not just this lesson, but we'll use it in other units. So just keep that in mind. So right here, here are some examples of inequalities graphed and written interval notation. So right here, we have x is greater than -4. So x is all the values larger than -4. And so here's the number line depicting that right here. So from -4 and then basically continuing on indefinitely, that's what that arrow indicates. This is going to continue on forever. And so also right here, you'll notice that I have a parentheses around that -4. That indicates that we don't include -4, but approaching it. So what that means right here, because we only want values greater than -4. So like, -3.9 would be fine, or -3.99. We could just keep adding nines, but we can't get all the way to -4. And so that's what I mean by approaching. We can just keep adding more decimal places that get us closer and closer, but we don't actually get to include the -4. Now, the interval notation is kind of similar to the graph. You actually just put the smallest value to the largest value from left to right. So in this case, it's -4, 2, and then we don't have a largest value. We say it's unbounded. And that's what the infinity symbol represents. It's not an actual number. It just represents the concept that the number is going to keep continuing in this positive direction. And so with the -4, we use the parentheses because we're approaching it. We don't include it. And then with infinity symbols, we always use a parentheses because you're approaching larger and larger numbers. Like I said, it's a concept. It's not an actual place. So you never actually arrive at infinity. It's an aspiration to get larger and larger. So you don't actually get there. Let's look at another example. Right here we have x is less than or equal to 14. So less than or equal to, so in this case we use a bracket around the 14 on the number line right there. And that little bracket indicates that the 14 is included. And then we want all the numbers that are less than 14, right? So it's unbounded this time, but going to the left, which would be going towards negative infinity. And so that's why we have negative infinity right here. And then the largest value is positive 14, and we get to include it. So we use that bracket. And then once again, with infinity symbols, we never use the brackets. We always are going to use parentheses. So you want to be careful. A common mistake students will make on this is they'll do this. They'll say, okay, from 14 to negative infinity, and that's incorrect. So you don't want to do it that way. Remember, it's always going to be from your smallest value to your largest value. And then our last example right here is going to be, we're going to have two conditions placed on our solution set, our values right here. So part of it saying, you know what, x needs to be greater than -2. If you're reading this from right to left, x needs to be greater than -2, but less than or equal to +4. So a lot of times, like I call this the squeeze. You're getting squeezed between two values. You're getting squeezed between -2 and you're getting squeezed between 4. Now with the -2, we have the parentheses because of the x is greater than. It doesn't have the equals to, so we don't get to include -2. And then less than or equal to 4. Now we do include the 4, so I have my bracket there. And then you can see that that's my interval notation right there. So whenever you have those whenever you have two conditions on it, typically you're not going to have that infinity then involved. Okay, so just a couple things to keep in mind. I've probably already highlighted most of these, but uh, keep these things in mind. Parentheses indicate that the endpoint is not included, so parentheses. The bracket indicates that the endpoint is included. Parentheses is always used next to the infinity symbols. And then when using interval notation, this is an important thing. The smallest value in the set always goes first. Like I said, that's a common mistake we'll see that I highlighted right here. So just be careful about that. So negative infinity will always be on the left. Positive infinity will always be on the right. Okay, so starting right here, it says convert the interval notation to the inequality and graph it. So we're going to kind of go in reverse. So now they're giving us the interval notation and they want us to come up with the inequality notation. Well, let's see. This set of numbers is numbers from -2 to infinity. So those are all numbers that are larger than or equal to -2. So my values, we'll call it x. X is greater than or equal to -2. That's what this is. Now, if you really wanted to, you could write it like this. -2 is less than or equal to x. It's the same thing. So if you switch the sides, you have to reverse your inequality symbol right there. And then, but I'm going to go ahead and erase that because typically we like to write it like I did the first way. Now it's time to graph this. And so really you're just drawing a picture from -2 unbounded to the right because positive infinity. So, you know, this is just going to be a generic sketch. You don't have to do anything too crazy. So I'm just going to put -2 here because we're going to include it. I put the bracket and I'm just going to shade this direction to positive infinity. And then maybe I'll just add a couple other points like here's -3, here's -1, 0. And really I didn't have to add that, but I think this is how it's going to kind of look on your homework. It's either going to be multiple choice or you're going to have like some tools where you can select them and then pick this and then shade a certain direction. Now, something that might kind of help you, and this is kind of a trick, okay, is that if you always have your variable on the left side, if you always have the x on the left side, you could kind of look at your inequality symbol almost like an arrow. So if you look, it's kind of like it's pointing to the right, so you're going to shade to the right. And so if it would have been like this, pointing to the left, I would have shaded to the left of that number. And so once again, it's kind of a trick to kind of help you, but the variable has to be on the left side because if you flip it, if we were to flip this, what's going to happen is you can see that now it's pointing to the left, so then I would actually do the opposite. But um, just something that might help you when you're doing these to help you remember which way to shade. All right, so our next one, let's see, our solution sets from negative infinity to +4, but not including 4. So really what we're saying is we want all numbers that are less than 4. So x is less than 4. And so that's my inequality notation. And then now we're going to graph that. So once again, let's see, we'll put 4 right here. And so I want values, x is all the values less than 4, like 3, 2, 1, 0, and then all those negative values. So go in this direction. And then if you want to, you can add a couple extra numbers just to kind of indicate that you've got your number line right here counting down to the left. Oh, and very important, I got to include my parentheses right there. So include my parentheses notation. By the way, sometimes, and you might see this, sometimes we use the notation of open and close circles. So sometimes with brackets, you might actually just see a closed circle. And we'll actually use that notation later on when we're looking at the Cartesian plane, the x and y plane. And then with parentheses, you can use an open circle, and that indicates the same thing. So if I were to kind of bubble that in or put an open circle right there, that notation is fine also. All right, so moving on. So right here, now we're going to give you the inequality. Go ahead and sketch a graph, and then go ahead and give the interval notation. So here we are. So x is all the values that are less than 6. So just put 6 somewhere on here. It's kind of arbitrary. So here's 6. I want values less than 6, like 5, 4, 3. That would make this true. If I were to plug in any of these values right here to the left of 6, that would create a true statement because all those numbers are less than 6, right? If I try to plug in 7, that's not going to work. 7, that would be a false statement. 7 is not less than 6. So that's which way I'm going to go, and then I have to put my parentheses right there, and that's my graph. Then my interval notation. Now be careful. This is where a lot of times we'll see a mistake. You have to be careful. You have to go from negative infinity to positive 6, and then parentheses on both of those. Okay, on part B, you'll notice that my variable is on the right side. You can leave it there if you want, but a lot of times students do not like that. So what we'll do is we'll actually go ahead and switch the two sides, but you do have to reverse your inequality symbol. So now we're going to change that to greater than or equal to 5. So I just kind of basically pick it up and flip it over, and so when I do that, the inequality symbol is going to reverse direction. And then let's see from here, let's see, I'll subtract 21 from both sides of that inequality. And then let's see, we're going to have x is greater than or equal to, I believe that's negative 16. So x is greater than or equal to negative 16. So like negative 16 would be about right here. And then this is actually going to count from negative 16 to negative 15 to negative 14 and so on. And then over here, it's like negative 17 and so on. And we want values greater than. So remember, it's pointing to the right, so I'm going to shade to the right. Sometimes this is where students get a little tripped up whenever we have the negative signs, right? Because it's weird. It feels like we're counting up to the left and down to the right, but we're not because of the negative symbol. We're counting towards 0 right here. We're going towards a positive direction to the right, and to the left, your numbers are just becoming larger negative numbers. And so then my interval notation here is going to be from negative 16 to infinity. All right, so moving on, we're going to do some more of the same, but we need to talk about a property here. So note, when solving an inequality, if you multiply or divide each side by a negative value, you must reverse the direction of the inequality symbol. And so here's an example. If A is less than B and C is negative, if we multiply both sides by C, which is a negative value, you notice I had to reverse my inequality symbol from being less than to a greater than. Same thing if I were to divide both sides by this negative C value, I'd have to change that less than to a greater than symbol. And then I have an example right here. So consider multiplying or dividing this inequality by negative 1. So we all agree that 4 is less than 5, right? We see this right here. 4 is less than 5. We can all agree on that. Well, if I multiply or divide by a negative 1, I'm going to end up with negative 4 and negative 5. Now, in this case, negative 4 is greater than negative 5. So see, negative 4 is right here on the number line. Here's negative 5. The greater numbers are always to the right, okay? So negative 4 in this case is greater than negative 5. So if you multiply or divide by a negative value, you have to reverse that inequality symbol. And so we're about to see that on example C right here. So right here, to solve for x, I'm going to divide both sides by negative 9. So that cancels out, and I'm just left with x. But now that greater than or equal to is now going to be a less than or equal to. And then 36 divided by negative 9 is negative 4. And then from here, I'm ready to graph it and give my interval notation. So let's see, negative 4 is right here, and I want values less than negative 4. Well, the values are less to the left, like -5, -6, -7, so on. So I'm going to shade that direction, and then I do bracket that in because of the inequality symbol. We have the equals two parts. So -4 is part of my solution set, and then so it's -5, -6. All those values are less than or equal to -5. And so then my interval notation is going to be from -infinity, that has to go first, and then to -4 and bracket that in. So remember, -infinity is always on the left, positive infinity will be on the right if we're dealing with a positive infinity. Okay, so for my next one right here, we've got 5 times x is less than -20. So I'm going to divide by 5, divide by 5. That cancels out. X is, so what happens here sometimes is students are like, oh, I'm doing division, there's a negative. And they instinctively think, oh, I got to reverse my inequality symbol. But I'm not dividing by a negative, I'm dividing by a positive. So in this case, you do not want to reverse your inequality symbol. So it's going to stay a less than, and then -20 divided by 5 is -4. So in this case, do not reverse the direction, because my divisor, for my example, if you look up here, my divisor, it has to be negative, and in this case, I'm actually dividing by +5. So just be careful. So let's see, x is less than -4. Well, that's interesting. It's actually pretty much identical to the one up above. So -4, -5, and so on, going that direction. And we're going to shade that direction also, and we're going to put a parentheses on it. So let's see, this one's going to be from -infinity to -4 parentheses. So almost the same solution. The only difference was the bracket and the parentheses. All right, so moving on. So now they're going to get a little bit, they're going to require a little bit more algebra, but other than that, it's pretty much going to be the same approach. And so moving on from here, I'm really going to focus more on interval notation. If you need to make yourself a little graph, then go ahead and do that. But really, I'm more concerned about the interval notation because, like I said, that concept's going to carry over into other units of the course. So here we go. So I need to solve for x. So I'm going to subtract by 11 on both sides. And so then I'm left with 5x is less than, what is that? Let's see, 15. Then we're going to divide by 5 on both sides. And we're going to get x is less than 3. Okay? And so x, it's all the numbers less than 3, like 2, 1, 0, and then all the negative numbers. So that's going to be from -infinity to 3. And I want to use the parentheses on both of those. Okay, on F, there's a couple of different ways you can approach this. We could either add 8x to both sides, or we could subtract 3x from both sides. It doesn't really matter. I'm going to go ahead and just subtract 3x from both sides. And so let's see, that will give me -11 x's in total on the left, minus 11, less than or equal to -13, because that cancels out. Then let's see, I'm going to go ahead and add, I'm sorry, not 13. I'm going to add 11 to both sides. And so let's see, now we're left with -11x is less than or equal to, let's see, what is that? That's going to be -2. And then we'll divide by -11 on both sides. Now when I do that, I will have to reverse that inequality symbol. So now we're going to have x is greater than or equal to, and then the double negative, this is going to become +2/11. Okay, so all you need to know here is the x values are larger than 2/11. I know it's a fraction, but don't overthink this. You want values larger. Well, larger values go to the right towards positive infinity. So our solution set's going to be everything from 2/11 towards positive infinity, right there. All right, so moving on. More of the same here. So let's see, what do we want to do here? This time, you know what? I'll subtract 4x from both sides. I could subtract 6x from both sides if I want, but I'm going to go ahead and do it this way. And so that cancels out. And so then I'm left with 6 is greater than or equal to -1. And then this is going to be plus 2x. And then let's see, then we'll go ahead and add 1 to both sides. So we're going to get 7 is greater than or equal to 2x. And then we'll divide by 2 on both sides. And so we end up with 7 over 2 is greater than or equal to x. Or if you want to flip it around, then you do have to reverse your inequality symbol if you're going to flip the two sides. X is less than or equal to 7 over 2. X is, and think about it, if you read it from right to left, that makes sense. X is less than or equal to 7 over 2. So you want to be able to read it both directions. But a lot of times we like to rewrite it with our x on the left side. So then our interval notation is all values less than this. Well, all the values less than this are going towards negative infinity. So that's going to be negative infinity and then approach, or actually including 7 over 2, all the way to 7 over 2, which is 3.5. If you really wanted to do a decimal, that's fine, but the problem with decimals is the one up here, 2 divided by 11, that decimal is not very nice to work with. And so that's why we typically, if we have a fraction, we typically just leave it as a fraction. All right, so if we look at h, what I'm going to have to do here is I'm going to start by distributing that 4. So let's see, we're going to get 28x plus 48 is greater than or equal to 8 minus x. And then let's see, from here we want to solve for x. So the easiest thing would probably be to add an x here, add an x here. And so we'll go ahead and cancel that out. And so 28x plus 1x basically. So I'm going to have 29x now. And then let's see, plus 48 is greater than or equal to 8. And then now my next step would be to isolate my x. I isolated it to one side, but now I want to get it completely alone. So I'm going to start by subtracting both sides by 48. And now I'm left with 29x is greater than or equal to, that's going to be a negative 40. And then we'll divide by 29 on both sides. And so we end up with x is greater than or equal to negative 40 over 29. Okay, so x is going to be our solution set, all the values that satisfy this inequality, and we're looking for values that are bigger than this number. Well, numbers get bigger as you go to the right on a number line, right? They count up. So this is going to be my smallest possible value right here. So that's going to be my first value right here, negative 40 over 29. And I do get to include it because of the equals to. I want values that are greater than or equal to this value. So we include that. And then values that are greater than that would count up. They would go towards positive numbers, right? And then include all the positive numbers. So that's going to go towards infinity. So once again, infinity, just a concept that explains that we're starting from here and we're going to increase indefinitely. Okay, let's try another one here. So we'll start by distributing the negative 6. So let's see, we've got negative 16x plus 8 is less than negative 6x, and then this is going to become plus 24. Now I have two options here. I can add 16x or 6x to both sides. I'm going to go ahead and add 6x. If you want to do it the other way, that's fine. And go ahead and, pause it and try it and see if we end up with the same thing. We should. So let's see, I'm going to cancel that out. So let's see, I had negative 16, but now I'm adding 6, so now I'm at negative 10x. Then I have plus 8 is less than 24. And then we'll go ahead and subtract 8 from both sides. And that will cancel out. And now we're left with, let's see, negative 10x is less than, let's see, what is that, 16? And then here we're going to divide by negative 10, so be careful. because we're dividing by a negative, so we're going to have to reverse that inequality symbol. Okay, so now we're going to end up with x is greater than, and then we do want to reduce this. If you notice, 16 and 10 are both divisible by 5. I'm sorry, not 5, 2. 2 by 2. And so this is going to reduce down to 8 over negative 5. 8 over negative 5. And if you did it differently, maybe the negative's up top and not on bottom, because it makes no difference. It's the same thing if I put the negative with the 8 and make the 5 positive. It's the same thing. Okay, so x is all the values larger than that. So we're approaching negative 8/5, but we don't include it. And then we're increasing indefinitely, and that's what the infinity symbol represents. So x is all the values starting here, but not including it, and then getting larger, larger, and larger, and continuing to include larger and larger numbers. Okay, so we have one slide left. And what we're going to look at is the compound inequalities. So what you can see here is we have two conditions placed on my variable. And so what we want to do is go ahead and isolate x, and then we'll go ahead and apply those conditions. So we're going to start by subtracting by 3 everywhere. So you actually have to do it in all 3 parts. So sometimes I like to draw these lines to kind of keep everything kind of separated. And so what happens here is the plus 3 minus 3 cancel out. 6 take away 3 is 3, and then I have my less than x, and then less than 8 take away 3, which is 5. So x is getting squeezed between this. So x has to be greater than 3, but it also has to be less than 5. Okay, so let's see. Let's put some numbers here. 2, 3, 4, 5, 6, 7. Okay. So on one hand, we're saying x needs to be greater than 3. So parentheses, and then I start shading, but be careful. Oh, I went too far because there's actually 2 conditions. So I'm going to undo that. The other condition is I have to stay less than 5. So see, I'm getting squeezed between those 2 numbers. So I have to be somewhere between 3 and 5. And I can't be 3 or 5 because then that would not follow those conditions, because 5, yeah, 5 is greater than 3, but 5 is not less than 5. And same thing with the 3. So that's what we're looking for right there. And so what you'll notice is when we have these compound inequalities, typically they can get kind of interesting to where maybe infinity could be involved, but we're not going to deal with anything like that in this class. But it's possible for these to get kind of a little interesting, a little tedious, but for the most part, I kept them fairly basic. So let's go ahead and look at another one here. So I'm going to draw those lines, kind of help me keep track of everything. So I'm going to start by adding 4 everywhere. So let's add 4 everywhere. So that will cancel out. Now I'm left with 5 is less than or equal to 5x, which is then less than 9. And then we're going to divide everything by 5. And that will cancel out. Well, 5 divided by 5 is 1, less than or equal to x, which is then less than 9 over 5. So I'm getting squeezed between these 2 numbers. And this, by the way, is like, that's about 1 point, or it is 1.8. But like I said, for the most part, we'd like to kind of just keep things as fractions. If you put it as a decimal, I think you'll be okay. But like I said, sometimes they're irrational, which means they're decimals that continue on forever. And so we don't like to deal with those. We want to have exact answers. So it's just good to be in the habit of using fractions. And so we're getting squeezed between 1 and 9/5. And we get to include the 1 because we're greater than or equal to 1, but we do not include the 9/5 because we have to be less than that. So we're getting squeezed between that right there. And so I'm going to go ahead and put that right here from 1 to 9/5. All right, last one. So once again, we'll go ahead and draw all those. And let's see, we'll start by subtracting 4 everywhere. And let's see, we're going to get negative 14 is less than or equal to 4x, which is then less than 5. And then now we need to divide everything by 4 and reduce where possible. So right here I can reduce this to negative 7 over 2, which is then less than or equal to x, which is then less than 5 over 4. And so we're getting squeezed between those two numbers right there. So like I said, this part's a little arbitrary, just kind of spread them out a little bit here. So let's see. And then let's see, the first one is included, so we're going to bracket that in. Second one is not included, my other endpoint. And then we shade between. And so my interval notation is from negative 7 over 2 to 5 over 4, and then we'll put a parentheses right there. Okay, so that covers our inequalities, and so we're actually going to be using this in the next section. So make sure you've got a good grasp of this section before you move on to the next one.